Now we can kind of start from the layout. So let's do that. Okay, so firstly I'm just going to change it to multi-layer mode. Okay, so yeah, so again I just want to show you a few more changes. So that is I got the reply from the manufacturer for our stack up, and there they have suggested two changes on the dielectric thickness and the core thickness for the first two layers. So I can show you that as well. So that I've already implemented, and I just want to show you. So they are suggesting instead of using this, because they are saying our PCB is going around 1.8, it is more than 1.8 mm. So they are suggesting we can reduce these two sections on the both side of the board, like on the top side and the bottom side. Okay, so I've already made that change. And whenever you do that change on the stack up, because we have already defined the impedance profile, so you have to just go to the design rule and edit that as well. So I can show you that. So open the layer stack manager. Yeah, so as you can see here, I've already made that change. Okay, it is in mm right now, but I reduced that. Okay, and after changing anything on the layer stack up, you'll see a lot of errors on this section. So how you can avoid that? Firstly, you have to just kind of refresh all the rules. So you'll see all these things will be kind of red, and you have to just go to each and select this impedance profile one more time. And when you do that, these all parameters will be updated. Okay, after that you can remove all the tracks, whatever you're getting the error, and you can reroute those. Okay, this is the solution. Okay, so that is one thing I did. I'm going to note down that as well. So, and this image is attached on the zip file that I'm going to share today. So for layout and planning section, we have changed a few things on the stack up. Okay, so that is one thing. Now okay, so as you can see, we'll start from the G1. Okay, the group 1, byte group 1. Okay, and for that we have to define same kind of, you can say stubs, or you can say the fan out connections with the vias for both of these. So as we have decided, we're going to use layer 1, which is this one. Okay, so how to do that? So firstly we have to set up few things. So when we place the via on this section, and how we basically do that, we place the via here. Now we'll just place a stub. So firstly we have to just rename that. Okay, I place that on the differential, so it will be little. Okay, so let's rename that with DM0. Okay, after that we'll go to the bottom layer and just connect that. Just make a straight connection. Okay, now we'll select the layer 1 and route it the same way. Okay, now we'll select all these three, Control C, or you can say Control X here. Now remove these extra copper. Okay, and we're going to place that on this one, so we can use it as a template during the connections. So let's start with these byte group 1. Okay, so now we have to decide how we're going to place, like what will be the orientation of this fan out. Either we're going to place this way or this way, or upside down like that. So as you can see, I've routed that on both of the layers, right? So on the bottom layer it will be connected, but this will be a kind of leading connections, and that will be in the same orientation where we're going to connect those. For example, if I'll select that again, so how we're going to make the connection? We're going to make the connection like this, right? It's like this, or it can be go like this as well, right? So these both of these orientation is kind of correct, right? So we're going to use this one. Okay, so here instead of masking those, I'm going to use dim. Now place these. Okay, why I'm getting error here? Okay, so again, yeah, I forgot to change one more thing. So again, this VI is through hole right now. Okay, and we've already defined multiple VRs when we'll be changing the layer. So this will be coming from layer 12 to layer 6. Okay, so now it is perfect. So then there will be like no short circuit between the top layer component on this one. Okay, so here you are seeing few errors. That is because of differential track. So that we will correct that later. Okay, now in case of this one, now here we have to place those. So for that you'll see some issue here. So when I'm going to place the same dimension of via on this section, okay, it's fine. I thought there will be errors. Okay, so again, okay, I forgot to add one more thing. Hold on. So that's why there is no error, because we forgot to add one design rule here. So what is that design rule? That is the same design rule that we saw on the impedance table. And according to that table, they are saying DQ routing trace width and the spacing within the same byte group, it should be greater than or equal to 2 times of the width of the trace. Right, so whatever the trace width we have, there will be the clearance between the signal either on the same byte group or on the different byte groups, or between the DQS and DQ signal. Okay, so that means on LPDDR4, whatever the number of signals we are using, the clearance should be greater than the twice of the width or equal to the twice of the width. Right, so we're going to implement that design rule on our design. So how to do that? Go to the design rules, and that is that rule is related to clearance. So I'm going to add new rule here. And what is that? It is for DDR byte group. Okay, what are the signals on this byte group? It is DQ, DQS and DM. Okay, now so here we have two options, right? Either we can use you can say same byte groups that we have defined, for example DDR G1, G2, G3, G4. But if you want to club all those together, so you have to define one more net class on your schematic design. So I'm just going for this one. How to do that? Here we have to write a custom query. So before that I'll select the net class, and from here I'll select the DDR. Now I'll select the custom query. So it will kind of create a template. Now here you have to use OR, copy all this string and just paste it here. This is for G2, G3, G4. Okay. Here we have to put some space. Same here. Okay, and change that to G2. This will be G3 and this will be G4. Okay, so all the byte groups that we have covered here. Now what will be the clearance? So if you'll see the width, so I've already measured that, and here the width is 3.24 mil. Okay, so again we have to just multiply it by, so again you'll see why I'm using 3.24 here, right? Because we're going to route our tracks on layer 1 and layer 3, right? And layer 3 is kind of thinner than layer 1 because of dielectric thickness and all this stuff, because of stack up, right? So but for clearance I'm just going to use the maximum one, which is from the layer 1. Okay, so that is what I got, and the value of this one will be, the twice of 3.24 is 6.48 mil, right? And apply. Okay, so now you will see we can't able to place the via here. So let's wait for a few seconds. If I'll cancel this one, then we can't able to see the errors. Okay, so now you can see, now we can see the clearance issues, and that is kind of verifying, okay, our design rule is successfully implemented on the design, right? So now if I'm going to place the via, and you'll see this problem. See, there is a clearance problem here. Okay, but we have to place the via here. Okay, and again, why we are putting clearance between the tracks? To avoid the interference and crosstalk, right? And the answer is same for this as well. We can reduce this width, or this clearance for between the pad and via. Okay, that's why on the design rule they have sectioned that into multiple things. So if I'll drag that, you can see this particular rule is kind of implemented for different clearances, for track to track, for SMD pad to track, but our interest is between the SMD pad and via. Okay, so we have to reduce that, and yeah, I've already calculated that. So how I measured basically this one, so you can simply Control M and hold the control key, so you can kind of follow the grid, and from here you can see what is the clearance here. So it's 5.48. okay, it's not properly placed. Okay, now you can measure. So this is the copper. Okay, so it's around 6 point something. So if we'll decrease the clearance for the via and SMD pad to 6 mil, then this things will be resolved. So go to the design rule, and we have to reduce this to 6 mil. Just double click on this one, 6 mil, apply. Okay, so let me note down this point as well. So here what I did, the second thing is, after stack up, you can define the template for layer change or for fan out. Then you have to define the clearance rule as per design guidelines. Let's see if it is resolved. Okay, hold on. Okay, so we have resolved this one. Now what we're going to do, we're going to assign one of these net. So just double click on this one, copy the net name, double click on this as well, paste, and just route on the top layer. Firstly, we have to just change the via. So from where it is coming from, 1 to 6. Okay, and route on the another layer as well. Now select those, Control C. Okay, and we're going to place this template here that we're going to use several times. Okay, so now select the group 1 again and we can assign those. So again, you can visualize that the clearance is very very tightly calculated, because see, we can play with the rules as less as possible. That is because we can't able to simulate this one. So we after the design and manufacturing we can able to see the potential problems, but to avoid those we have to design something in a very ideal way. So yeah, so I would recommend you to just try to avoid all the potential problem that comes from the clearance or something like that. So till here, now what is the next step? So in the next step we're going to route the connection. So before that I just want to draw a few section here. Okay, so generally what problems that that I already did in my previous few designs with RK339. So what I did, so you can see here we have one byte group, here we have another byte group, right? But our connection is kind of in this section, right? Similarly we have third byte group here. So when we route these things from here, we kind of place all the connections in this section. We can route those from here as well. We can kind of spread all the connections too much. Okay, so that can be a problem because see, our vias are overlapping, right? So that means the via that we're going to use from top to L1 and another via which is we're going to use for top to L3, right? So that means this via is kind of can create short circuit, right? We can't overlap these vias, right? Because that via is crossing the L1 as well, right? So to avoid these kind of problem, what we do, we kind of section those. How we do that? So for that we're going to use overlay. So let's select the overlay here, select one line, and what I'm going to do, I'm just going to draw. Okay, firstly just make it thinner. Let's go for 3 mil. Okay, so what I'm going to do, I'm just going to route or place a small line in this section. So it will kind of give me understanding, okay, this byte group is ending in this section, so I'll not cross this section or trying to route or place via in this section. Okay, similarly for this as well. So as you can see, what is another byte group? Another is here. Same thing you can do for the another LPDDR4 as well. Okay, so this is the last one. So from here we can see, okay, these are the byte groups that we have to connect, and we don't need to cross these connections, at least in this area. Okay, apart from that, in this section we can cross, okay, because here we don't need to place multiple vias. All the connections will be pretty direct, but in this section we have to avoid the via placement or something like that, which will be create problem later. Anyways, let's start the routing.